Hi guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of integration, and this question has been appeared in the boards many times. So I'm taking up this question. It says I is equal to integral dx upon sin x plus sin 2x. Right. So first thing I can think about here is to simplify this idea. We already know that sine 2 theta is 2 sine theta cos theta. Right. So I can use the idea here that tells me integral of dx upon sine x plus 2 sine x cos x. Further, what I can think about is from the numerator, I can see sin x can come common here. So if I take sin x common, what I get is 1 plus 2 cos x. Now, further, if I want to solve this further, what I can do is 1 plus 2 cos x. I can put cos x as t, but the derivative of that is sin x, right? So let's adjust that sin x in the numerator. So what I will do is I'll multiply both sides by sin x. So I'm multiplying the numerator as well as the denominator by sin x. So that gives me sin x dx upon sin x into sin x becomes sin square x and 1 plus 2 cos x. Now I can apply one more idea here that sin square theta plus cos square theta, I know it is 1. So here I can write sin square theta as 1 minus cos square theta. Right? Or I can simplify this as 1 minus cos theta and 1 plus cos. So if I simplify sin square x, I can write here it as sin x dx upon sin square x. I can simplify this as 1 minus cos x, 1 plus cos x and 1 plus 2 cos x. Right? Now everything is in terms of cos x in the denominator. So we can substitute cos x as something now. So I can put cos x as t. So here I will get minus sin x dx is equal to dt, or if I write it in terms of the numerator, sin x dx becomes minus t, right? So now if I replace my I, that is my integral, it will become I is equal to integral of minus dt upon, I can write this as 1 minus t, this is 1 plus t, and this is 1 plus 2t. So this becomes 1 minus t, 1 plus t, and 1 plus 2. Right? Now, if I want to write it in this frame, first of all, by partial fractions, I can write this entire fraction in terms of a upon first part, that is 1 minus t, plus b upon 1 plus t, and c upon 1 plus 2t. Right? So first of all, let's try to write it in this form and find a, b, and c. So what I'm doing is I am writing this and write here integral and dt also. So what I'm doing here is I'm comparing minus 1 upon the product 1 plus t into 1 plus 2t. Now, if I want a common denominator on both sides, that is on the left hand side and right hand side, what I get here is a, this gets 1 plus t and 1 plus 2t, plus b, I will have 1 minus t and 1 plus 2t here, and c will have 1 minus t and 1. Right? So basically, all the three terms I'm multiplying with product of the three terms. So in the first part, 1 minus t gets cancelled. So we are left with these two terms. In the second part, 1 plus t gets cancelled. So we are left with these two terms. And in the third part, 1 plus 2t gets cancelled. So after that, what I get is product would become 1 minus t into 1 plus t into 1. Okay. So we are taking the LCM basically of the fractions here. Now I can directly see the numerators are same. So I can compare the denominators. So minus 1 becomes, if I solve this further, it gives me a into 1 plus 2t plus t plus 2t square plus b, it becomes 1 plus 2t minus t and minus 2t square plus c 1 minus t square, right? So if I further want to write this, it becomes 1 minus 1 is equal to a. This is 2t square plus 3t plus 1 plus b, it is 1 plus t minus 2t square, and this becomes c 1 minus t square. Now if I further try to take out t square common from all of the terms, this becomes 2 into a, right? Here also if I take out t square common, it becomes 2 into b, so it is minus 2 into b. And from here also if I try to take out t square common, it is minus c. So the whole thing common is t square. For t, if I try to find it out, it turns out 3 into a. Here I have plus b into t, right? And here I do not have a term of t, and for the constants I have a into 1, so a, b into 1, so b, and c into 1, so c. So if I write this part left hand side also in terms of this, I can write this as 0t square plus 0t and minus 1. So if I compare both the left hand sides and the right hand sides, I get three equations. Basically, let's write it on the next page. So the first equation here I get is 2a minus 2b minus 2c is equal to 0. The second equation I get here is 3a plus b is equal to 0. 3a plus b is equal to 0. And the third equation I get is a plus b plus c, that's equal to minus 1. So a plus b plus c is equal to minus 1. Right? So these are our three equations. Now let's solve these three equations and get the values of a, b, and c. So first thing what I can do here is, so if I see here a plus b plus c is minus 1 and 2a minus 2b plus 2a minus 2b minus c is equal to 0. So if I add all of them, what I get? So if I add all of them, the c gets cancelled. Minus 2b and plus 2b also gets cancelled. So I directly get a here, and that becomes 2a plus 3a 5a plus a, so 6a is equal to minus 1, and a here I get it as minus 1 by 6. Further, if I get a, I already know 3a plus b is equal to 0, so b becomes minus 3a, and here if I find out, it becomes minus 3 into minus 1 by 6, right? So that 3 ones are 3 twos are, and minus into minus makes it plus, so half is the value for b, right? I get a, I get b also. If I substitute a and b in this third equation, I get c also. So if I want to find out c, a plus b plus c is given to me as minus 1. So c becomes minus 1 minus a minus b. So minus 1 and minus of minus 1 by 6, that is plus 1 by 6, and minus half. So minus 1 plus 1 by 6, so it becomes minus 6 plus 1 minus 5 by 6 minus half. If I make the denominator same here, it becomes minus 5 minus 8, so it is minus 8 upon 6, and that's minus 4 by 3. So c becomes minus 4 by 3. I have all the values with me now, that is a, b, and c. So our integral which was present, that was I is equal to integral of minus 1 dx upon 1 minus t, 1 plus t, and 1 plus 2t. So instead of dx, we need to write it as dt. That was 1 minus t, 1 plus t, and 1 plus 2t. We can easily now replace that with three terms that for a, b, and c. Right? So I can replace this entire thing with three terms. So I'll write it as a upon 1 minus t. A I already know it is minus 1 by 6. So it becomes minus 1 by 6 into 1 upon 1 minus t plus. Next I got b. B was half with 1 plus t. So half 1 upon 1 plus t, and I have also got c now with me, that's minus 4 by 3. So instead of plus, if we write here minus, that is minus 4 by 3, and that is 1 upon 1 plus 2t. Right? So entire thing is with dt's. I can apply separate integrations now. So if I apply separate integrations, minus 1 by 6 integral of 1 upon 1 minus t dt plus half integral 1 upon 1 plus t dt and minus 4 by 3 integral of 1 upon 1 plus 2 t dt. Right? Further, I can solve this entire expression minus 1 by 6. This becomes log of 1 minus t or log of mod of 1 minus t upon the integral of minus t. 1 minus t has the coefficient minus 1 for t, so it will divide it by minus 1 plus half. This is log of mod of 1 plus t. Nothing is left, so I'll write here 1 because the coefficient of t is 1, so we divide it by t minus 4 by 3 log of 1 plus 2t in the mod and dividing it by the coefficient again, so it is 2 plus c. So I can cancel this, 2 2s are, 2 1s are. Now what I am left with is, I can again resubstitute as I've got the answer. I can resubstitute t, we put t as cos x, right? So I can resubstitute the value of t here. So if I resubstitute, what I get? So minus and minus, I can cancel that as well. So I get 1 by 6 log of mod of 1 minus cos x plus 1 by 2 log of 1 plus cos x, and this becomes minus 2 by 3 log of 1 plus cos 2x plus, right? So this is our entire answer for the question which is asked to us, that was I is equal to integral of dx upon sine x plus sine 2x, and the answer we got here was 1 by 2 log of mod of 1 plus cos x, my plus 1 by 6 we got log of mod of 1 minus cos x, and minus 2 by 3 we got log of mod of 1 plus cos 2x plus c, right? So this is the answer for the question which is asked to us. So this is how you solve this. I'll revise it once again for you. What we did was, first we tried to simplify this entire expression of trigonometry. Once we simplified it, we put cos x as t, so sin x dx becomes minus dt, and once we use that, we get the equation in terms of three algebraic expressions. We can just solve it using by partial fractions by getting the values of a, b, and c. Once we get the values of a, b, and c, we can just substitute that and find the integration as log of something because it is 1 upon x, right? After that, we get the answer in terms of this entire expression with its three terms, which is log half of log of mod of 1 plus cos x plus 1 by 6 log of mod of 1 minus cos x and minus 2 by 3 log of mod of 1 plus cos 2x plus c, right? So this is how you solve the questions which are based on this type of integrals, where the addition of two trigonometric functions is given in the denominator. I hope you have understood how to solve this type of questions. We'll meet again tomorrow with the next question. Till then, you can subscribe to my videos as well as my channel because it takes lots of efforts in making these videos for you. Thank you.